In section 1.3, we'll be looking at lines and linear functions. We'll be looking at slope, and in particular, we'll look at slope as a rate of change of a function. We'll write the equation of a line in slope, intercept, and point slope forms, and then we'll use linear equations to determine other information that's related to the business applications that we've already studied. All right, so let's start with slope, and this is probably something very familiar to you since you've been studying it for a while. We're going to look at it a little bit differently. The way I want to think about slope in this course is as a rate of change. And by that we mean if you have a quantity that you can think of as some unit divided by some other unit, then that can be considered a rate of change, and we can think of that as a slope. So for example, when you're driving a car, your speed is determined in miles per hour. So whenever you have this unit per another unit, that's a good indication that what you have is a slope. Now, there could be some other units, but that's really sort of the key indicator for us is this unit divided by unit. Now let's go ahead and recall what the formula for slope is. So for a line, passing through the points x1, y1 and x2, y2, we have that slope is equal to m, that's the symbol that we use for slope, and that is delta y divided by delta x. And this symbol delta means change. So that literally means the change in the y's divided by the change in the x's. So you would get y2 minus y1 over x2 minus x1. Notice that the y1 and the x1 are on top of each other, and the y2 and the x2 are on top of each other. You have to maintain that order. The second minus the first, the second minus the first. Otherwise, you get the wrong answer. Okay. If we were to look at a graph of a line, let's just have this line here, like so, then the slope is the ratio between the change in the y's and the change in the x's. So if this is the first point and there's the second point, then going horizontally from left to right, we get the change in the x's. And going from this corner point straight up, we get the change in the y's. And so the slope is that ratio. Now what's interesting about slope is it doesn't matter how big you make this triangle. Suppose I were to come in and make this little triangle right here using these points that intersect the axes. Well, I now have a different delta x and a different delta y because the triangle is smaller, but it's still equal to the same ratio as the one before it. So the slope is constant along a line. In other words, it's going to be the same slope at between any 2 points that you choose. It doesn't matter which 2 points are chosen. Example number 1. It cost a publisher $400 to print 60 books and $760 to print 120 books. Find the slope of the publishing cost function, assuming it is a linear function, and then interpret. So first thing we want to do is we want to get some ordered pairs here. Ordered pairs are in the form of x, y, and then what do we normally use for our x's? Well, we normally use the units that are being sold, the quantity that's being sold. So in that case, or in this case, in this problem, it would be books. And then we normally make the y's the money value, so that's going to be the cost. All right, or you can think of that as the dollars. So the 2 points that are given to us in this problem are 60 books, comma, $400, and 120 books, and $760. And now we want to find the slope for this publishing cost function and then interpret what that means. So I'm going to use our formula. M is equal to delta y over delta x. So I'm going to take the difference in the y's. So it's going to be $760 minus $400. And notice that I'm including the units here, and I'm doing that for a very specific purpose that I'll show you in a moment. Divided by 120 books minus 60 books. And notice that I used y1 and y2 and x1 and x2 in the same order whenever I did those calculations. So let's see what we get. 760 minus 400 is $360. Divided by 120 books minus 60 books is 60 books. And you do the division, and you get $6 per book. So notice that the units provide for this slope. It's dollars per book. Those are the units. And that tells me that this is a slope. So let's interpret what this means. So each additional book cost $6 to publish. And that's the interpretation. Example 2 says, using the information above only, determine the cost for publishing 121 books and 122 books and explain the solution. So basically, if you know a specific point that refers to this situation, then you can use the slope to sort of add on to it. So in this case, we had this point right here. 120 books cost $760. And now we know the slope, and that it cost an additional $6 to publish each new book. So 121 books is, we're going to take that base value of $760 and we're going to get $766. And then if I start with 120 books, that was $760. And I want 122 books, then I'm going to add 2 times the $6, because this slope has been changed by 2 factors, because it was 2 additional books. And that is $772. And so the explanation is basically what we have above. Each additional book cost $6 to publish. Therefore, we can start at $760 for 120 books, and add in each additional book. Next, let's take a look at the slope-intercept form. Oh, we know this one. Find the equation of the publishing cost function from above. So we want to use the slope-intercept form. Slope-intercept form is y equals mx plus b, where m stands for the slope and b stands for the y-intercept. So I'm going to use the 120 books and the $760. And the books is the x, and the $760 is the y. So we get 760 is equal to our slope, 6, times our x value, 120, plus the b value representing the y-intercept. And then if you just solve this for b, we get 760 is equal to 720. Move that to the other side, and you get b is equal to 40. So this would be y is equal to 6x plus 40, but we know it's a cost function. So let's go ahead and change it over to c of x is equal to 6x plus 40. Another form of the equation that we use a lot is called the point-slope form. The point-slope form is y minus y naught is equal to m times x minus x naught, where m is the slope and x naught, y naught is just equal to some point that's on the graph of this equation. So we'll use the same pieces of information to create the equation of the publishing cost function in the point-slope form. So for y, I'm going to use c of x. For y naught, that's my $760. M is still 6. And then we have x minus 120, because the 120 and the 760 go together. Now this technically is in a point-slope form, but this is usually not the form we leave it in. We do one minor simplification, and that is we move the 760 to the right side, and then we leave that. Now, if you were to keep working this out and simplifying it as much as possible, you would just end up with the slope-intercept form from above. So the rationale for having this form is that you can read off these pieces of information readily. Here's the slope. This number and this number are the two components of a point that goes on that line. Now you have to be careful. This is in the form of x minus the number, so the number is really 120. This is plus 760, so it is 760. So one of them is opposite and the other one is straight up the way it should be read. Example number 5, graph the publishing cost function. So I'll go back to the original one that we found, which was c of x is equal to 6x plus 40. That tells me that the y-intercept is 40, which is going to be about right here. Notice the scaling on the y-axis. And then to help me find the other points, I'm going to go ahead and draw in the points that we already know, which was 60 and 400. And then 120 and 760. That right there. And there you go. There's your cost function. Example 6. Use the publishing cost function to determine the cost of publishing 140 books. Mark the representative point on the graph. So this is the number of books. Books are equal to x, so that means we want c of 140. You can use either of the two equations from before. I'll just use the first one. So it's 6 times 140 plus 40, which is $880. Now the point that gets created from this uses the x, which is 140, and the y, which is 880. And now go back to the other page and mark that point on the graph. So 140 and 880 is right there. And we'll label it 140, 880. Example 7. How many books can be published for $1,600? So the question is, what does $1,600 represent? That is a cost, because it's money, which means it's the y value. So I'm going to use the original equation again. I'm going to get $1,600 is equal to 6x plus 40. And now we solve for x. So move the 40 over. You get 1,560 is equal to 6x. And then divide both sides by 6, and we get 620. And the units would be books, because this is an x value. And now, example number 8. Bob suggests using a different printing method with different paper and binding. This new process would result in a cost function C2 of x is equal to 3.5x plus 260. Question A. Discuss the differences between these two cost functions. All right, so let me put up our cost functions here. So we've got the first one was 6x plus 40. And the second one was 3.5x plus 260. So go ahead and pause the video and think about what the differences might be, and then hit resume or play to check your answers with mine. But pause the video now for just a few seconds to see what answers you could come up with. All right, here are the answers that I was able to come up with. So if I look at the two equations, the first thing I notice is we have a 40 here and a 260 here. These numbers represent the cost that is incurred when you print 0 books. They call that the initial cost or the fixed cost. It is the cost associated with doing something, in this case printing, that does not rely on the amount of items you are producing. So it doesn't matter if I print 1,000 books or if I print 2 books, I still have to pay these initial costs. And so the first thing I notice is that C2 has a larger initial cost, also known as the fixed cost. And then what else can we determine? Well, now I look at the slopes. So I've got a 6 and a 3.5. And what do the slopes represent in each of these equations? Well, we already discussed that when we talked about slope earlier. They represent the additional cost per book. So the original C function we had cost $6 per book to print, but this new one cost $3.5 to print. So I would say, but C2 has a smaller individual additional publishing cost. And that's per book. So those are some things that I observed. And then part B is the real question. This is the question that your bosses will come to you as a business major or someone who's working for them. They'll say, okay, well, which one of these is better? Is Bob's new process better for the company to adopt, or is it not? Think about that one for a second. Pause the video and see if you can come up with the analysis that answers this question. All right, so hopefully you had a time to work that out. And the answer, unfortunately, is, well, it depends. And what does it depend on? It depends on how many books are published. So one is better for one situation, and the other function is better. In other words, the other process is better in another situation. So now your boss is going to want to know, all right, well, which one is which? How do I know? How am I going to know? So what we want to do here is called a break-even analysis. It's similar, but just slightly different from the other break-even stuff that we've done already. But it's basically the same idea. So the break-even analysis. The break-even analysis in this case is going to determine how many books we can publish and have the exact same cost function or cost value, even though I'm using two different functions. So where does it break, in other words? So the way we do that is we just set them equal to each other. And we solve for x. So we get 6x plus 40 is equal to 3.5x plus 260. Solve for x, we get 2.5x is equal to 220, and x is equal to 88 books. So there's where it breaks. Okay, so that's good. We know where it breaks. Now the question would be, which one is better on which side of 88? So let's do a graph. So here's x. Here's C and C2. And I'm going to graph C first. So C had a y-intercept of 40 and a slope of 6. So pretty steep going that way. And that's C. And then I'm going to graph C2, and C2 had a much higher initial value, so that's the y-intercept, but it had a much shallower slope. So it doesn't have the same kind of rise that C does. So that means they eventually cross, and where do they cross? Right here. That's the break-even point, which is 88 books. And now we can answer the question. So which one is better and when? So in this section right here, C has a lower cost. So C is better, cheaper in other words, if less than 88 books are published. And then C2, which would then be this piece right here, is better. And I'm picking these up because they're smaller, they're lower numbers. So whichever graph is lower is the one that is the winner, right? Because the lower the graph is on the grid, then that means the cheaper it is. So C2 is better if more than 88 books are produced, are published, rather. And then, of course, we didn't mention anything about 88 except that it's the break-even point, which by definition means that they cost the same at 88 books if you use either method, so it doesn't matter. So it's either it's less than or it's more than, and then in the 88 we don't care. All right, that's it for this section. Thanks for watching.